Ted Feldman of Durin, do you have a plan for the goblin issue?
Great question. I'll get it all the time. You need to know exactly how deep you are to make sure you don't delve too deep. It's just a matter of having the right sensors on the rig, but also the sort of drilling we're doing, very, very small diameters, so you can't get too large monsters.
Ted, have you seen, like, I mean, there's a long history of science fiction films where people dig and bad things happen. Have you seen The Core?
Or no, I have not.
You should never see it. It's a terrible film.
Well, let's talk about your actual company for a second.
Yes. So Durin builds and operates exploration drilling rigs to find critical minerals. And so basically what this means is you're collecting rock samples, which you can then analyze in a lab. Once you pull the rocks up, you chop them up into whatever sort of increment the geologist wants. You'll ship it off to a lab. They'll grind it down into powder, put it in some machine that will tell you the exact chemical composition. And so what this enables is you can plug all this data into a 3D geological model, and you've drilled hundreds of these holes, and you have hundreds of samples per hole. You're able to visualize your body in 3D and make a determination of whether the deposit is economic to mine, and then develop a mine plan. And so we're focused on this. Drilling is the most important part of exploration, about 70-80% of the cost of exploring for a mine. So prior to permitting, 70-80% of the cost. And so a very, very substantial and important component of exploration.
Let's imagine you deploy and everything goes perfectly. I mean, perfectly for Durin. What are the benefits and consequences 5, 10, 20 years from now for the U.S. economy if Durin wins?
Yeah, so let's break it down. So exploration drilling right now, it is labor constrained. We have a severe talent shortage in the mining industry broadly, particularly in exploratory drilling. This is you're often in remote sites, doing difficult work in the hot and cold. Not many people want to take these jobs. So we don't have enough guys. And so it's difficult to get a crew on site. And as a result, it's very expensive to do this sort of drilling. Labor is 50 to 60% of the cost. You're looking at $250 around there a meter in the Western US and Canada. And so what does Durin enable? We're trying to automate all that, make sure that you don't need someone standing by the rig all the time, putting rods in place, automating controls. The complexity of this core drilling is that you're drilling down a kilometer, often more, and you're going through many different rock layers. And depending on the sort of rock that you're going through, you need to drill with different parameters. So you're basically constantly adjusting your RPM, the amount of weight on the drill bit, the fluid pressure that you're pumping downhole to clear the cuttings and keep the bit cool. You need to change the drill bit depending on the sort of rock that you're doing. You need to add additives to the drilling fluid depending on the porosity of the rock, or if you're going through a void. There's a bunch of variables that are constantly being adjusted. If you're drilling a 40-foot hole, you can drill with a constant RPM weight on bit. It doesn't matter. That's on the control side. You also have all the kind of manual tasks you're going to need robots to do. So that's putting new drill rods in place. All drilling is basically screwing rods together, twisting and shoving them downhole, but putting a new rod in place is a non-trivial task. You need to actually have some person today grab a tool called the overshot, which you then send down the pipes that you're drilling with, the drill rods. It latches into the top of the assembly downhole, and you're able to pull up the inner tube containing the core sample. And you have a guy manually grabbing this inner tube, putting it down on a table, unscrewing the top, and then banging on it with a hammer to get the rock out. You have guys who are manually adding these additives to the drilling fluid. You guys who are greasing the rods, making sure they're lubricated so they slide together nicely. So there's a bunch of these small tasks that add up to be quite a complex robotics problem, in addition to the controls problem of adjusting these parameters based on the sort of rock that you're going through.
You're sensing, checking, resistance, like torque variables, like all of that stuff. Is that happening at the top, or is that happening
all
at the end?
Surface.
Okay.
All at the surface, yeah. You basically drill string telemetry, so figuring out how you get data from downhole to the surface is a non-trivial problem.
Because you know your length, then you can correlate against that. Yeah,
exactly. You can put sensors downhole, and we're going to be looking at this later on. Sending data to the surface in real time is very difficult because you have fluid going through all this, very noisy environment. Or if there's technology called mud pulse telemetry used in oil and gas, where they'll vibrate something in the mud downhole and then sense the vibrations. You get like 5 bits a second with that. You do acoustic, which is a little bit better, but also noisy, very lossy. So often, like, once you've drilled a certain amount, or maybe when you drill the entire hole, you can send down like a magnetic sensor to detect sort of magnetic properties, the rocks around there. Often while you're drilling, you basically pull up the inner tube containing the core sample. You can send down alternatively a gyroscope so that you know your exact position downhole in case your hole deviates. You're trying to hit a specific target 500 meters down. You might sometimes miss it if you don't know your exact position, and you can adjust accordingly. And so integrating that downhole while you're drilling will be very interesting. It's just a matter of just figuring out how to get the data off of it. And also, you'll often while you're drilling, not super often, but it does happen, kind of the dirt or rock around the drill string can collapse around it, and you'll basically get stuck. And oftentimes you'll have to leave your tools down hole, abandon the hole. And if you're using some of these gyro sensors cost $250,000, you don't want to lose a $250,000 piece of hardware down hole while you're drilling. And so it's easier to play it safe and send it down after.
So, a few months ago, there was a story about how I think a vast mineral field was discovered in the United States, and it would take, 10, 20 years to
Yeah.
unearth it. A large portion of minerals in the United States are in protected lands. Is that right?
Yeah.
Let's imagine. One of the first things on your website is that we rely on China for our
Yes.
rare earths. Okay, if Durin executes perfectly, I'm going to keep coming back to this. And those protected lands were no longer protected. Does the United States possess, free of policy or technical limitations, does the United States possess the rare earth sources it would need to decouple from China?
Big picture here. So rare earths are a subset of a category of elements called critical minerals. Critical raw materials. So it's basically a whole bunch beyond rare earths that are critical. Rare earths is it's a synonym for the lanthanides on the periodic table. The most important four being neodymium and praseodymium as the light rare earths, and then terbium and dysprosium as the heavies. These are super important for rare earth magnets for electric vehicle motors or wind turbines. I used to work about a year and a half for Epi Materials, which operates the one active rare earths mine in the United States. The U.S. basically has one economic rare earths deposit. There's Mountain Pass in California. There are no others that I know of, and that any of my friends who are analysts in this field know of that would be economic to extract. We definitely have deposits. It's a matter of, can we produce them at competitive cost? And so rare earths, we produce around 15% of global supply. That's enough for a lot of the rare earth demand, but we'd like more. And so we should be importing more rare earths. We should be extracting more domestically, which would require a lot more exploration to find additional deposits. Look at something like cobalt. The cobalt's super important for batteries. DRC in Africa is the largest producer by far. The U.S. does not contain any high grade economic resources of cobalt, and that's not an issue because there's this kind of not an ally necessarily. They should be, but not China that possesses vast deposits of them. And cobalt prices are very, very low right now. Production has been ramping up incredibly high. It is not a huge issue to import that from the Congo. We should be refining them here. China dominates a lot of refining of these metals, even more so than they dominate mining. China has many raw material resources for primary extraction in country. What China is very strategic about is importing those and then doing the refining step in country. And so I think the U.S. should take the same approach and say, okay, there are plenty of resources, take like copper, that we have a lot of in the United States. For what we don't have enough of, we should be building refining in-house. But for those resources like copper or lithium that we have plenty of in the U.S., we should be spending a lot more money and time exploring for them and then extracting them in the U.S. And then, yes, a lot of our mineral resources are on federal land. NEPA is the primary regulation that prevents us from extracting them. Basically, anyone can sue to stop these projects if they have a problem with it. And so you end up having these lawsuits and permitting uncertainty that these lawsuits go on for 10, 15 years. I think the best example of this is Thacker Pass, a lithium deposit in northern Nevada. Finally got final permits recently, and will be built in the next couple of years by Lithium Americas. But that was a 15-year battle to get those permits. This is a deposit that should have been built 10 years ago. We know it's economic, and we've known it's been there for 25 years. I'll kind of walk you through. There's a ground where geologists might think there's something there. We have a producing mine, and so the best place to find a mine is next to an existing mine. And so there's a lot of kind of jurisdictions or districts that we know contain mineralization. I think copper in Arizona is a great example. Freeport McMurray has like 5 or 6 mines there, all within a relatively close area around Phoenix and Tucson.
What is the absolute shortest timeline from you getting a phone call from the office of the president to someone extraction on what's currently protected land, to somebody extracting what you have found?
Now, I think you're better off drilling on many more projects and pushing that out to 1 or 2 years. But also, like, there are some deposits where, like next to an existing mine, where we know that something is probably there. And then it's a question of permitting. Let's say permitting is an issue. Build an open pit mine, call it 2 years to remove all the overburden, field processing. So you can get these things up and running in 3 or 4 years, like at the absolute limit. But capital is the constraint right now. Capital is a constraint. We're trying to make it cheaper. We're trying to turn the capital problem into a technology problem. The USGS is already working on this with kind of very wide spacing, focused on just learning about the ground, not specifically looking for minerals. And so I would do kind of a nationwide geophysical survey, concentrate on the areas we think there are valuable minerals. So we call it the Western US, particularly the Southwest. And so I would do all this for a year. You're going to need probably thousands of planes to do this right, with a pretty tight spacing. But that's how I would start. Make all this data public. This is a service. And then you have private exploration companies or major miners come in, and I would say sell them kind of mining concessions on federal land, because most of where these mines are is in the Western U.S. on federal land. Like in when was it, 23 or something like that, Defense Production Act allocated a certain amount of capital towards critical minerals projects. So I think it was Talon Metals that got around $20 million just to spend on drilling at their nickel project in Minnesota. And also like this feasibility work, we already know what the deposit is. You're trying to figure out kind of exactly the size of it with tight spacing. That's where there is capital lacking. That's where it's least exciting for often these companies are public, and so they're reliant on retail interest. That's where there's the least retail interest relative to like the size of the project, the amount of capital they need. So oftentimes after discovery is made, when you're doing this kind of quote unquote boring infill drilling, companies' caps may slide, and that's where they need to raise the most capital, and that's often when projects die. If you look at there's a chart, which is Mining Finance 101, called the Lassonde curve, and it basically has on the y-axis like the market cap or value of an exploration company or mining company, on the x-axis time. And as you make the discovery, the y-axis goes up, but then when you're doing this feasibility drilling, you'll often see a dip, a trough, when the value goes down during this infill drilling, and then you get into permitting, it's kind of the bottom of the trough, and then during construction and ramp up, the value will increase to maximum value when the mine opens. But trying to decrease the magnitude of this drop in the Lassonde curve is really what we're trying to do by making drilling cheaper and faster. And I think government funding can help do that as well.
You obviously understand the space, and I'm presumed that you did not decide to get into mining after you had fallen in love with drilling. Like, what is your like background and history in minerals and extraction?
Yeah, so I grew up with a family in mining, specifically mining finance. My dad and my uncle. I've been talking to them about mining for pretty much my entire life. Started working in the space during my senior year of high school, an internship with a company called Hyperion X. They were exploring a titanium deposit in Western Tennessee. Through that, went really deep on the titanium supply chain and saw that basically everything was going through Russia or China, which was very concerning to my 17-year-old self. And so through that, became very interested in critical minerals, but then also kind of fell in love with the treasure hunt of finding mineral deposits. And so through college, worked for MP Materials, a couple of other exploration companies, as well as went to a whole bunch of conferences, talked to thousands of people in this industry, was looking for what are the biggest problems to solve, the biggest technology problems. I'm studying computer science, love robotics and programming, and so I'm going to figure out how I can apply that to mining. All of the focus over the last 10 years has been on electrification of this equipment as opposed to automation to hit energy transition targets, as opposed to like the more immediate workforce constraints. And so that's why I decided to start the company nearly a year ago, was to bring sort of the SpaceX caliber engineering talent to this industry. As a solo founder, started this during my junior year of college when I was at Georgia Tech, and ended up moving to California, LA, El Segundo that summer of 2024. Basically flew back and forth between Atlanta and LA to finish up exams before graduating in December.
I'm going to give you a bunch of allowance, or actually I'm going to take away a bunch of allowances that I should, in fairness, give to you, which is your company just started, you're a solo founder, you're just getting a lot of this stuff off the ground. But my first thought is literally, yes, I see a workforce shortage. I see a lack of R&D budgeting within these exploration companies to account for it. Great. But it still seems to me like it would be easier to go train up 1,000 new wildcatters or whatever they're called, and not, I don't know if they would, if it, outside of oil and gas, they're wildcatters, but to go train those people with the off-the-shelf equipment that's there, then invest in a new, currently unproven and in some ways much more complex solution.
And so, yeah, I think it just comes down to like, I do not want to be constrained by having to train up a workforce where it's 1-to-1, you need 3 people for 1 rig. I would rather build a system that over time goes from 3 people for 2 rigs to 3 people for 10 rigs, eventually 2 people for 20 rigs or something like that. And eventually these things can drive themselves from the factory out into the field and just start drilling. And so yeah, I think there are definitely short-term fixes that you could do if you poured money into education. But also, it's like there are drillers who love this job, but it's a tough job. And so there are better things for people to be doing with their time, like building the future of this job.
Is it reasonable to say, like, if the cost and execution cost goes down, that there would also be some advantages to be able to do even more core drilling, both from having a better understanding of what's actually below the surface, but also to be able to, in the case of something like an open pit mine, be able to not have to have as big of mine because the extraction is more targeted.
It's always great. It's always a balance and exploration of like how much money you have versus how much you're spending on data collection.
We're gonna use you as representing all of the mining industry, so we can continue to educate ourselves on geostrategic, NatSec questions. But Alex and I both come from the automotive world at times. Like, we know a lot about EVs and battery. Give me like a 60-second. This is what the U.S. could have in 4 years, and this is what we'd have on our territory, no knowledge of any of these major essential resources. If there was a hot war, or if there was some reason, like where would we be screwed?
So first of all, in energy, we should be building on a massive nuclear fleet. Nickel, we have a good amount in the U.S., primarily in Minnesota and Michigan. Higher cost than we're getting in, like Indonesia is so cheap. But we should be building some domestic mines as well, potentially government supported.
Is that Ice Age like deposits?
I forget the geology of that. It's northern Minnesota, the Duluth complex.
Okay, fair enough. Keep going.
Okay, army stuff. So tungsten, antimony are very important. Tin is growing massively, and a lot of tin is basically comes from dredging off the coast of Indonesia. And there's just one mine in the DRC that produces a bunch. That's very strategic. I don't think we have any major deposits of that here. Antimony and tungsten we should be producing in the Western U.S. I don't think we mine any tungsten or antimony in the United States currently. I could be mistaken. And then catalysts, so platinum group metals, we don't have much of. I think there's one mine in, I believe it's South Dakota, that we have, which is very, very expensive. Now we get a lot of from South Africa. So I think there's plenty that we should be forging alliances about. Copper is the one that we need to see the most growth in, and that we can produce a lot of domestically.
You are signaling something to the world by naming your company Durin. Not anymore. If you would have started the company 8 years ago and called it Durin, it would have been like, oh, cool, he's a Tolkien fan, like, he's doing all this stuff. Now, very much between being based in El Segundo and then also pulling a Tolkien name. And again, I mean this sincerely. What do you think it means to say, I'm starting a company and I'm going to align myself with these other Tolkien companies?
Fan of Lord of the Rings for much of my childhood. Those were very formative books. I'm a Tolkien fan. Tolkien was a bit anti-industrial, but he also, I love the environment. I don't want to destroy the environment or we need to mine better responsibly. Tolkien's a very devout Catholic. I respect that. I'm a Catholic as well. There's the kind of personal connection. I think it's a really cool name. Like, I don't think there are very many kind of fantasy sci-fi things that are as clearly associated with mining as Durin. The initial idea, I was actually on a flight to El Segundo about 1.5 years ago, and was rewatching Fellowship of the Ring. I was like, oh, I should call the company Moria. And then I thought about it. I'm like, no, that's a pretty negative connotation. And so then I was thinking, what was Moria called before it fell? And the dwarves called it Khazad-dûm, and the elves called it Hadrodran. And I thought both of those were really cool names, but a little bit long and complicated. So who built it? Durin built it.
What was Durin's bane? Was that the Balrog,
the monster that they encountered by delving too deep?
But wasn't there something specifically called Durin's bane, or am I misremembering Lord of the Ring?
Because Durin the first king, he's the one who dug too deep, and it ended up really coming back to bite them. what I tell people is that I named the company after Durin the Seventh, his descendant, who came back and kind of restarted the kingdom and brought it back to its former glory and lived happily ever after.
You've officially proven yourself to be enough of a Tolkien nerd that I cannot criticize you picking a.
Yeah.
If you needed our approval,
Good.
like you have it.
We're on the Lord of the Rings tip. Yesterday there was a tweet from the Babylon Bee, and it's a picture of Tucker Carlson with Saruman, and it's like Tucker Carlson asked the question listeners want to know of Saruman: when will Rohan stop agitating?
Yes. Yeah.
That was very funny. Okay, so there was one of my favorite shows, maybe my favorite TV show of 2024 is the Apple show, the alternative history show For All Mankind. Are you
I
familiar
love
with
that
this
show.
show?
Oh,
Yeah, I love
yes.
that show.
I
Okay.
would, the
So,
season 2 and season 3, like newsreels at the
yeah,
start, I would watch
yeah,
all the
yeah,
time.
me too. Have you been to have you gone on Apple? Was it Apple Plus? They have even more. Like they have dozens and
Yeah, I've
dozens of
seen the
little
extra
videos.
clips.
Yeah,
Yeah.
great stuff. Great stuff. In season 4,
Yeah.
space mining is the central plot point.
Yes.
So, all right. Who, if any, is there anyone else that specializes in space mining? And what is the applicability of what Durin is doing to mining in space in the future?
Yeah, I think the most legitimate company in space mining now would be Astroforge. They're based not too far away from me in, I think they're in Orange County or Long Beach, something like that. They have, I forget the exact details of the technology. It's like a satellite that goes up, lands on an asteroid, and then it's some sort of laser that kind of releases the platinum particles found in the rock that they're on, and they're able to collect it and send it back to Earth. I think that might work. Now, I think they had some communication issues with their first satellite launch over the past couple of weeks. Unfortunately, they were able to launch, and some things went well. And what I think it's really interesting there is that if you don't have humans underground, you don't need to build an extra ventilation shaft, you can drastically lower your capex. What we need to figure out is, like, if something goes wrong, how do you have all robots fix it without any people going down? And so, but I think that's where we go next, is automating drilling equipment in underground mining. That's a much larger market than this exploration drilling piece we're starting with.
There is a subset of next gen companies that are selling the narrative that humanoid robotics are everything. Oh, everything will be solved by humanoids. Everything else is a waste of
Yes.
time. And they're imminently here at scale. Is there a role for humanoid robots in mining, or are purpose-built robots the more cost-effective and effective
Yeah.
solution?
Purpose, but you could probably get anything done with humanoid robots. You could build an artisanal mine with humanoid robots if you wanted to. It would be an efficient way to mine.
Gonna circle you back a little bit. How much do you have to invent blank slate in the sensor top of the pipe engineering?
In state-of-the-art rigs, you basically have all the data you would need to do this. It's a software problem, and like actually using that data. So historically, you have all these gauges the drillers looking at. Yes,
To
exactly.
loop it back
And
to
so
control.
historically, with these gauges that the drillers are looking at, they're listening
see.
to it. None of that data is being stored. Only like in the last few years, we actually started to store what is the driller doing, what lever is he pulling, what is the data every 0.1 seconds. And so no one is really, in no release product yet, are we actually using that data to adjust the controls. And so it's a matter of like, just teaching the software how to drill, understanding what the driller is looking for, and then actuating everything accordingly.
One of our very first episode with our friend Russell Verone made an offhanded comment about walking into a machine shop and being able to tell how tuned all the machines were by the harmonic pitch. And it's like, that's effectively what sounds like what is in drilling, which is what's your horizon look like? When are you like ready to have like your first
So
like soup to nuts test?
our first rig is nearly done being built. We've done about a week and a half recording this mid-March. And so after that, we'll do a few days of testing in the office, make sure everything moves. Then we're mobilizing to northern Nevada. We're doing a pilot test with an exploration company in a gold project a couple hours east of Reno. And we'll be up there for probably 6 weeks drilling our first few thousand meters with this first rig. This one will go down about 300 meters with call it 2.75 inch core diameter core sample, HQ sized rod. And so we'll be testing, we're drilling very soon. This is manually operated. What we've built here is what I'm calling a programmable rig. It's basically an API for every data source, everything that moves on this, so that when initially we'll have a driller with an iPad operating this, just a manual UI replicating the physical control panel, be storing everything they do. And then basically as he is reacting to a pressure spike or torque increasing or rate of penetration drops, basically be taking note and starting to build a like V1 assisted autopilot system, which then hopefully over. What's great about this is building our own rigs and operating them. Like this software should be improving every day, shipping over the air updates, trying a whole bunch of different approaches, trying like a new algorithm on fleet of 10 rigs, and then if that works, deploying it to the rest. Really, it's a platform for doing a whole bunch of interesting software things.
Two things. One, I'm super happy for you. I just feel like that's going to be such a cool experience for you to take, your company, your first rig out in, like, I also love Nevada. Like, it's just pretty country, and it's like, that's going to be such a cool experience. But who else, like, how big is the company now? Did you have a co-founder? Like, where are you at just as far as the development of the company?
Full time right now. Myself, head of operations, mechanical engineer, and software engineer, looking to hire more imminently. We need a mechanical engineer, software engineer, and controls engineer. Incredibly high bar. You're looking for the best engineers to work on this problem with us. Incredibly cracked team so far. And so, small team. We started designing this rig in mid-December. It's going to be about 3 months from starting CAD to testing a $250,000 rig that weighs 6 tons. So we are moving very quickly, and we want to continue that. And
thank you for coming on. It's I don't know why, like, we just met, but like, I'm just really,
thank you.
I'm really happy for you. You're about to go on a really cool adventure. And I think what you're doing is important, and you're going to make a ton of mistakes, and it's going to blow up in your, hopefully not literally, but you know what I mean? Lots of things are going to break and go, but there's nothing better than having a great idea and getting a group of people together to work on it. So break a leg, and we'll check back in a couple of months and see how you're doing. But until then, thanks for coming on Tool or Die.